Today's lesson is lesson 3 on surface area using connecting cubes. I recommend that you have the connecting cubes in front of you and that you have built the shapes that we'll be using examples. Even as I'm making this lesson, I have the cubes in front of me. So example number 1 says build and determine the surface area of this composite object. Each cube has an edge length of 1 centimeter. So I'm going to show you 2 different ways that you can do this. So I have already created the object in front of me. So the first method is going to be to add up total exposed spaces. Okay, so in order to do this, we have to consider 6 different views. So the front view would look like this. If I were to take it and rotate it to the front, I'm calling this over here the front, we would have a diagram that looks like this, which has 4 surfaces in it. Okay, I would then also look at the back. Back is going to look exactly the same from a 2-dimensional standpoint. So it's going to have 4 as well. Okay, now let's look at the side. If I rotate this object to the side, I get a little L with 3 cubes. And both of the sides are going to look like that. So we've got side 1. You could call it the left side. Well, this one might be called the right side. And then side for the left as well. So you'll notice that these are very similar. They're just different orientation. Okay, both of them, however, have 3. Okay, and then the last one that we haven't considered is the top and the bottom view. So the top view is going to look like this. Yours might be different orientation than mine, but either way, it would make up 4 surfaces. And then the bottom would be pretty similar. Okay, so that would have 4s as well. So then in order to find the surface area, we would just take all of those numbers and add it up. So 4 plus 4 plus 4 plus 4, so 4 4s, which is 16, plus 3 plus 3, which is 6. So that would give us 22. And then we have to pay attention to units. In this case, it told us each cube-like has a side of 1 centimeter. So that means it's 22 centimeters squared as our final answer. So that's one method. The second method is to find the surface area of all 5 cubes and subtract the overlap times 2 times the overlap. So I'll do my best to explain this to you. However, without the cubes in front of me, it's a little bit more challenging. So if I find the area of all 5 cubes, I'm choosing the number 5 because there are 5 cubes making up my shape. Each cube has 6 faces. So each cube by itself has, a surface area of 6 sides. So that means that 6 cubes, or sorry, 5 cubes would have 30. Now that 30 includes some parts that are together, right? So we know that the cubes sticking together, those don't count towards our surface area. So what I do is I take the shape in my hand and I count how many times I'm pulling it apart. So if I pull it apart, I have to pay attention to how many faces are coming under lap. So there's 1, overlap, 2 overlap, 3 overlap, and 4 overlap. Well, you have those cubes in front of you, and you can do that. So the overlap, well, there are 4 places where there was an overlap, and each of those removed 2 from our surface area. So that's 8. Now we take our original, our 30, and we subtract the overlap to give us 22 centimeters. So both those options work anytime we are trying to find the surface area. You just get to choose which one you like the best. Okay, let's try another one. This is the last example. It says build and determine the surface area of this composite object. So I'll give you a second to go ahead and make that shape. I'm making it too. And then you get to choose the method of your choice to find the overlap or to find the surface area. So I'm still making the shape. I'm going to do both methods just briefly for you, so I'll draw them out. So I'm going to label this, my front, and this is my side. And I'm just going to start drawing the different views that I see when I rotate that object. So when I rotate this one to the side, or sorry, to the front, I'm doing front first, I get a staircase. This is the front. And it looks like that is 6 cubes. And then I'm going to do the back, rotate my object around to the back, and it's that same thing, just reversed. So also 6. Then I'm going to take at it and look at from the side. Now the side kind of turns into that same shape. This is the side. So that's 6, and then the other side is going to have 6 as well. I'll draw it out. So the only thing that I have not done yet is the top and the bottom. So I'm going to flip it to the bottom and I get an L shape, a bigger L than the last example though. That has 5 in it. And then the top has 5 as well. So go ahead, add those numbers up. We get 6 plus 6 plus 6 plus 6 plus 5 plus 5. It gives me a total surface area so far, total sides, I should say, of 34 sides. So this one we have to pay a little bit more attention to what the dimension of a cube is. So it says each cube has an edge length of 2 centimeters. So if I were to just take one face of that cube, it says that the edge of it is 2 centimeters for both sides. So that means that this square here actually has a surface area, or an area of 4 centimeters squared. That's for one side. So I take my sides, 34 sides, and I multiply it by 4 to find out how much I have in total. So it's going to be 136 centimeters squared. Okay, using that same method as method number 2 that we did for the second part of example 1, we could find that exact same answer. So I'll go ahead and count up my cubes. To make this object, I needed 3, 6, 9 cubes, and each one has 6 faces. So 9 times 6 is 54, but then I have to subtract the overlap. So the overlap is simply done by pulling your shape apart. So I'm going to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So take that number and multiply it by 2 to get 20 overlap. And then we're going to take 54 and subtract 20 to get the answer of 34, which is the exact same answer that we got last time. Then we take that 34 sides and we multiply it by 4 to get the same answer of 136 centimeters squared. So you choose which method you like best, and that's the one that you use for answering these types of questions.